Hi, everybody. This is Mr. Folly, and whoops. Welcome to Podcast 1.3, where we are going to talk about measuring again, how they have a numbered, unnumbered, and estimated digit, because our measurements have blurred lines. Use the density equation to do math. State density is independent. State that more dense things sink. Talk about a graph of density and differentiate between physical and chemical changes and give the 5 evidences of chemical changes. Let's hop right to it. How many numbers to report? So remember, there's an unnumbered, a numbered, an unnumbered, and estimation. By the way, you don't have to draw that one. Woo! So if I'm looking at this, there's a numbered part of 3, an unnumbered part of 1, 2, 3, 4, and it's right on that spot. So that's going to be 3.4. Now I need an estimation. 0. Okay, so if you look at that in the 3.40, then you should know you've got, it's either going to be 3.39, 3.40, 3.41, and that's good. Okay. When you're reading a graduated cylinder, we know we have to go to the curved part of the meniscus. So here's 60. My numbered part is 60. My unnumbered part is 1, 2, 3, 4, 5, 6. And then my estimation, it's a smidgen above that, so I'm going to call it 66.1 milliliters. Oops, I almost forgot my unit. Okay, so numbered, unnumbered, and estimation. I got rid of that one because it counts by 2s, and that's just a bad device. Density is an intensive physical property. What intensive means is that it's constant and doesn't change. Okay, so an intensive property of an elephant is it always has a trunk. Intensive property of gold is that it's always yellow and soft. So that's what an intensive property is. You should write down what I just told you, the definition of an intensive property is. Density can be used for separation, because more dense things sink if they're not soluble. Okay? Soluble means that they'll dissolve. So if I put salt in water, salt is more dense than water, but salt dissolves, so you wouldn't really say it sinks. Density is a ratio of mass over volume, which means density is mass over volume. That's the ratio part. Don't write this down. Woohoo! This is just me trying to show you something clever. What weighs more, a pound of feathers or a pound of bricks? They both weigh the same. They both weigh a pound. I tricked you. But the reason why people say a pound of bricks weighs more is because it weighs more for its size. So if I'm talking about mass over volume, mass for its size, hey, that's density. So because a brick is more dense, people seem to think it's just heavier, which isn't the truth. Density is love. This should help you remember the formula for density. Look, density equals a heart with a knife through it. So mass over volume. So density is love. Let's do some of the math. So 100-gram sample. Grams measures mass. You should write this down and do this problem, or it's question number 6 in podcast on the pod sheet for 1.3, so you can actually see this in your homework. 4.669 milliliters, which is the volume. What is the density is what I'm looking for. Notice how I labeled each number. So if I know it's a density problem, all right, density equals love. And then the mass is a hundo. The volume is 4.669. And I ask my trusty calculator, which is always at my trusty fingertips. And 100 divided by 4.669 is 21.4. And then notice my units are grams for mass and centimeters cubed. So it's grams per centimeter cubed. 21.4 is A. Again, these problems are in worksheet 1.3 in your packet. Find the volume of an object that has a density, so that's my density, and a mass of this. So I'm looking for the volume. So density equals, here's number 3, m over v. So density is 3.14. Mass is 87.9. Here's volume. Now, this is Mr. Folly going all kinds of crazy on math for you now. Okay, I know you can show 6 steps to do this, and your math teachers teach you to do that, and that's not wrong. I think of math as a tool, and tools should be something you can use faster. A power drill is better than a screwdriver. Okay, so I'm going to show you that you can simply cross multiply everything that has an equation in physics and chemistry. So I'm just going to move this over. 3.14v equals 87.9. And then v equals, again, everything's cross multiplication, 87.9 over 3.14. Does the same thing, okay, I promise. So v equals 87.9. 87.9 divided by 3.14. And that is 28.0. And then density tells me my units, milliliters, because this density had milliliters for my units. Here's number 4. Experiment requires 21.4 grams of methanol. Mass. Density. What volume in liters will be required? So same deal. D equals M over V. Density is 0.790. Mass is 42.1. Volume is V. Cross multiply. Now check this out. I'm going to do them both at the same time. Woo! Okay, so V equals 42.1 over 0.790. 42.1 divided by 0.790 is 53.3. Remember, density will give you your unit, milliliters. Yeah. Water has a density of 1 gram per milliliter. Which of these objects will float in water? Okay, so if density is 1 gram per milliliter, in order to float, that means density less, in order to float, than water. Okay, so for object 1, D equals M over V. So 50 over 60.8 equals, I'm going to say more than 1. Okay, for 2, same deal. 65 point, wait a minute, that's not more than 1. That's less than 1. 50 divided by 60.8. Then with 65.2 divided by density equals mass over volume over 42.1, more than 1. And 3, mass is 100, density equals 100. Mass over volume 20. Okay, so which objects will float? So I need something with a density less than water. That means it is number 1 only. Okay, these other things have a density more than water, so they'll sinky, sinky, sinky. Sample graph of density. So mass, which is going to be in grams, volume, which is going to be in milliliters, and then I've got my little ticky, 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 ticky. Now densities of things form a linear graph. Hey, it's linear. So it doesn't have to have the slope of 1. It doesn't have to be like that. It could be, if it has a mass of 1, it might have a volume of 3. The mass of 1 would be a volume of 3. The mass of another one would be a volume of 3. And what happens is this makes a straight line. Okay, I tried to hit the lines. Let me try it again. Woo! Okay, close enough. So this slope equals density. Oh, how cool. So there you go. Physical changes. Hey, new stuff. Physical changes do not change the identity. If I boil water, guess what, kids? It's still water. Freeze water, it's still water. If I have an ice cube, I cut it in half, it is still H2O. If I have a piece of paper and I cut it, hey, it's still a piece of paper. If I fold it, that's still paper. If I paint that, it's still paper. And that's a Smurf painting things. Okay. Condensing means to go from a gas to a liquid, and melting, you know what that means. Okay. So physical changes do not change the identity, and that's the most important part. Physical properties do not have to do with reactions. They're just the way you describe them, right? Just describe without reactions. What's the density? What's the color? What's the hardness? What's the shape? What's the conductivity? So if I'm looking at a gold ring, I could say the density of the gold ring is the density of gold, 7.12 grams per milliliter. Color, gold is yellow. I'm colorblind, and I even know that. Gold is very soft. I can leave tooth marks in it if I chewed on my gold ring. Shape, it's my ring. It would be round. I forget what you call a ring for geometry, but whatever. Conductivity, yes. If you stick your ring in a light socket, it will go bzzz and hurt. Intensive or extensive. Remember when I said intensive is constant? Extensive can change. So you can change this and it's still gold. Density, remember, is an intensive property. Right? All gold has that density. All gold is yellow. All gold is soft. Is all gold round? Nope. That's extensive. Does all gold conduct electricity? Yes. So shape and size is another example of an extensive property. Chemical properties. Will it react chemically? Will it go kablooey? Will it change into something else? A chemical reaction changes the identity. It turns into something else entirely different. Hydrogen and oxygen have the chemical property of forming water. Notice water is extremely different from hydrogen. Look out! You're in a bunch of oxygen. You're going to drown. No, you won't. You're going to breathe and be fine. Okay? So water is all new from what it's made up of. Hydrogen explodes, right? So the chemical property of hydrogen is it explodes. Okay? Witches burn. So if I took a typical witch in our class, I don't know, Alexis, and set her on fire, it's go, oh, Alexis, the witch, has the chemical property of burning. Signs of chemical change. That means you have a new substance. If you have a chemical change, you have a new substance. And like I talked about burning witches. So if we really burned Alexis, then she starts out as a person or a witch, take your choice, and she ends up as ash, soot, I don't know the difference between ash and soot, please don't ask, and smoke. She's no longer Alexis. Okay. Heat is absorbed. That's the definition of endothermic. You should know that. Heat is released. That is the definition of exothermic. You should know that. I wrote that down. Color change. This would be, signs of chemical change would be color change. This is not painting or coloring. So just so you know, if you paint something, you don't make it something new. All right. Precipitate is where a solid forms, whoops, I can write forms. I can write solid forms from two liquids. And if a gas forms, by the way, a gas forms, but it cannot be boiling. All right, boiling forms gases, but not the same. Be careful, you must have a new product. That's why I told you how these guys can be trick questions. There's my trick questions. Be ready for them. So let's do some samples. Chemical change or physical change? Iron rust. Hey, iron changed color. Rust is different from iron. That's a chemical change. Water boils. I start with liquid water. I end with gaseous water. It's still water, even though a gas formed. That's my tricky star question. Ooh, boiling's a physical change. Leaves change colors. Well, leaves are like soft and supple and can bend, and change colors leaves are crunchy and dead. That's a new thing. That's a chemical change. Cheese molds. I love me some mozzarella cheese. This has new properties. It tastes like awful. So that's a chemical change. Jose dyes his hair. Well, does Jose's hair change color? Yes. But is it new? Is it still hair? Yeah, it's still hair. So because Jose frosted his tips, come check it out in class today, then you can tell it's a physical change because it's still hair. Rain falls. Starts out rain, ends up rain. Physical change. Review. Measuring has a numbered, unnumbered, and an estimation. Right? So you got to be able to read those blurred lines. And right now Miguel's thinking, oh, I saw that MTV thing. Oh, I think, what's her name? Hannah Montana is now creeping me out. Density is a ratio of mass over volume. That means this is the formula. And graphically is a straight line. And density is the slope. Chemical changes have indicators that change the identity. That is it. So before Robin Thicke swears, I'm going to say toodles.